Assalamualaikum and hi sir. Today we will present to you subtopic of chapter 2, which is atmospheric layer and circulation of atmosphere. Our group members is Muhammad Ikmal bin Abdullah, Muhammad Syami bin Muhammad Zulkifli, and Muhammad Nur Arif Zuddin bin Mustafa Kamal. Next, we look into atmosphere definition. This definition is a mixture of gases that surrounds any planet. The gases content is 21% of oxygen, 78% of nitrogen, and 1% of argon, carbon dioxide, neon, and helium gas. The density of atmosphere decrease with distance of Earth, which means the further the distance from Earth, the lesser the atmosphere density. And atmosphere will act as a shield from energy radiation. Without the atmosphere, there could be no life on Earth. Atmosphere contain the air we breathe, protect life from harmful radiation, help keeps planet heat from the sun from escaping back to space. It's a major element of the water cycle and keeps the climate on Earth moderate. Next is the importance of atmosphere. Why the existence of atmosphere is really helpful for the Earth. The first thing is for living things, especially plants need carbon dioxide for photosynthesis, which is carbon dioxide is one of the gases of the atmosphere. They use sunlight to change carbon dioxide and water into food, and also the final product is oxygen, which is really useful for human, animal, and also for plant itself. And also other living things depends on plants for food. Next is sun rays. The atmosphere protect the living things sun's most harmful rays. Gases reflect or absorb the strongest rays of sunlight. In other words, we know as a ozone layer. Next, the importance of atmosphere is Earth temperature. They keep the temperature in a range that can support life. The gases keeps out some of the sun scorching heat during the day, and during the night they hold the heat close to the surface so it doesn't radiate out into a space. Next is Earth's water. Water vapor raise from Earth's surface into the atmosphere. The water vapor may then condense into water droplet and form cloud. If enough water droplets collect in clouds, they may came together to form droplets. Droplets will fall as a rain. Weather. Without atmosphere, there will no rain or clouds or any weather on Earth. Most weather occurs because the atmosphere heats up more in some place than others. And lastly is for sound. Sound is a form of energy that travel in wave. Sound wave cannot travel in empty space, but they can travel through gases, which is in atmosphere. Gases in the air allow us to hear most of the sounds in our world. So without atmosphere, there will be no sounds at all in the world.
Okay, now I will explain about the atmospheric layer. Earth's atmosphere has a series of layers, each with its own specific traits. Moving upward from ground level, these layers are named. First is a troposphere, second is a stratosphere, third is mesosphere, and fourth is thermosphere, and the last one is exospheres. The exosphere gradually fades away into the realm of interplanetary space. Okay, now we move to the first layer, which is troposphere. The troposphere is the lowest layer of our atmosphere. Starting at ground level, it extends upward to about 10 kilometers, which is 6.2 miles, or about 33,000 feet above the sea level. We humans live in the troposphere, and nearly all weather occurs in the lowest layer. Most clouds appear here mainly because 90% of the water vapor in the atmosphere is found in the troposphere. Air pressure drops and temperature get colder as you climb higher in the troposphere. Okay, the next layer up is called the stratosphere. The stratosphere extends from the top of the troposphere to about 50 kilometers, which is 30 miles above the ground. The infamous ozone layer is found within the stratosphere. Ozone molecules in this layer absorb high energy ultraviolet light from the sun and converting the UV energy into the heat. Unlike the troposphere, the stratosphere actually gets warmer the higher you go. The trend of rising temperatures with altitude means that air in the stratosphere lacks the turbulence and updraft of the troposphere beneath. Commercial passenger jets fly in the lower stratosphere, partly because this less turbulent layer provides a smoother ride, and the jet stream flows near the border between the troposphere and the stratosphere. Okay, the next is above the stratosphere is the mesosphere. It extends upward to a height of about 85 km, which is 53 miles above our planet, and most meteors burn up in the mesosphere. Unlike the stratosphere, temperatures once again grow colder as you rise up through the mesosphere. The coldest temperatures in Earth's atmosphere, about 90 Celsius, are found near the top of this layer. The air in the mesosphere is far too thin to breathe, and air pressure at the bottom of this layer is well below 1% of the pressure at the sea level, and continues dropping as you go higher. Okay, next I will explain about the layer of very rare air above the mesosphere is called the thermosphere. High energy X-ray and UV radiation from the sun are absorbed in the thermosphere, raising its temperature to hundreds or at times thousands of degrees. However, the air in this layer is so thin that it will feel freezing cold to us. In many ways, the thermosphere is more like outer space than a part of the atmosphere. Many satellites actually orbit Earth within the thermosphere. Variation in the amount of energy coming from the sun exert a powerful influence on both the height of the top of this layer and the temperature within it. Because of this, the top of the thermosphere can be found anywhere between 500 and 1000 km, which is 311 to 621 above the ground. Temperatures in the upper thermosphere can range from about 500 Celsius to 2000 Celsius or higher, and the aurora, the northern light and southern light occur in the thermosphere. Okay, now we move to the last layer, which is exosphere. Although some experts consider the thermosphere to be the uppermost layer of our atmosphere, others consider the exosphere to be the actual final frontier of Earth's gaseous envelope. As you might imagine, the air in the exosphere is very thin, making this layer even more space-like than the thermosphere. In fact, the air in exosphere is constantly tough, very gradually leaking out of Earth's atmosphere into outer space. This is no clear-cut upper boundary where the exosphere finally fades away into the space. Different definition place the top of the exosphere somewhere between 100,000 kilometers and 190,000 kilometers above the surface of Earth, and the latter value is about halfway to the moon.
My name is Muhammad Noor Azuddin bin Mustafa Kamal. I will present about atmospheric circulation. The definition of the atmospheric circulation: the large-scale movement of air in together with ocean circulation. Thermal energy is redistributed on the surface of the Earth. The smaller scale where the system is known as mid-latitude dispersion. The large-scale atmospheric circulation cell shift polewards in warmer periods. The work produced by the engine causes the motion of the masses of air in the process. Next is a Hadley cell, which is a closed circulation loop which begins the equator. Moist air is warmed by the Earth's surface and decreases in density and rise. The rising air creates a low pressure zone near the equator. The Hadley system provides an example of a thermal direct circulation. The power of Hadley system, considered as a heat engine, is estimated at 200 kilowatts. As the air movement poleward is cool, become dense and descend at about 30 parallel, creating a high pressure area. The descendant air is traveled through the equator along the surface, replacing and the air that rose from the equatorial zone. So the Hadley cell is described as located in equator in the northern hemisphere and shifts the high latitude in June and July and toward lower latitude in December and January, which is a result sun hitting the surface. Next is a parallel cell, which is a mid-latitude cell. Part of air rising at 90 degrees latitude diverges at high altitude toward the poles and create the polar cell. The rest move toward the equator where it is collided at 30 degrees latitude with the high level air of the Hadley cell. There is subsidized and the strength at high pressure reaches beneath. A large part of energy drive parallel cell provided by polar and Hadley cell circulation on the either side and the drag parallel cell with it. In the upper atmosphere of the parallel cell, the air moving toward the equator divides toward the west. The mid-latitude are sometimes known as a zone of mixing. Next is a polar cell. The polar cell is a simple system with a strong convection drive. Through the cool and the dry relativity to equatorial air, the air mass is at the parallel are still sufficient warm and moist to undergo convection to the drive and thermal lock. Through cool and dry latitudes in equatorial air, when the air reaches the polar area, it has cooled by radiation to space and is considerably denser than the underlying air. The endless chain is a passing high and low, which is part of everyday life of mid-latitude dwellers. The polar cell terrain and katabatic winds in Antarctica can create very cold conditions at the surface. Next is worker circulation. It's predicting when the monsoon wind in India would fail. That's between the eastern and western Pacific, which is a term and the southern oscillation. The movement of air in the worker circulation affect the loops on their side. The worker cell play a key role in this and the El Nino phenomena. Upper level westerly wind will fail. Next is El Nino circulation or southern oscillation. El Nino and La Nina are opposite surface temperature anomalies of the southern Pacific, which heavily influence the weather on the large scale. Warm surface water approaches the coast of South America, which results in blocking upwelling of nutrient-rich deep water. There is also increased upwelling of deep cool ocean water and more intense uprising of surface air near the South America, resulting in increasing number isotropic occurrences.
That's all from our presentation, which is from definition of atmosphere, the importance of atmosphere, the layer of atmosphere, which is from troposphere into exosphere, and the circulation of atmosphere, which is from Hadley cell into El Nino. We hope what we want to convey is achieved, and thank you for your time, sir. Assalamualaikum and bye.